This video goes over how to solve logarithmic equations. At the top, here's an example of something called the change of base identity, which is how you can address equations where the base is different numbers. If the bases are different numbers, then all of the log properties don't apply, which might be why you would need to change the base. So here in this first one, we are rounding to 3 decimal places and we're just evaluating. This is one where we need to switch into exponential form. Then we need to take the log of both sides, which is going to allow us to bring down the exponent in front. Now we can divide both sides by log 3. And we can say that our expression is equal to approximately 2.854, which you would find using a calculator. In the second one, similarly, we would set it equal to y, change it into exponential form. Then we would take the log of both sides, which lets us bring the exponent down. Next, we're going to divide both sides by log 7. And our final answer tells us that that logarithm is equal to approximately 0.606, which we'd find using a calculator. The next example here has an x in it, where the argument of the log in it is, and we're going to solve, and we're going to state the exact answer where possible. So for questions like this with only one logarithm, we are going to change it into exponential form and then evaluate. For questions that have one log on both sides, we can actually write both so that they only have one argument and one log, or one term, on each side. If the first part of the expression is the same, that means that the insides have to be the same. So then we know that x is equal to 2 cubed, which means that x is equal to 8. C is similar. I'm going to bring the 2 up so that I have x squared on one side, and then I have log base 6 of 49. This is going to tell me that x squared is equal to 49. And normally, I would get 2 answers here. I would get x equals positive 7 or negative 7. But in my expression, all of my x values have to be above 0, which means that my only possible answer is for x to equal positive 7. So we are now getting into restrictions, again, on our equations, because our function has some restrictions. In this case, the argument of the logarithm has to be 0. Let's move on to D. Here we've got 2 logarithms on the same side. Because they have the same base, I'm going to combine them using my laws of logarithms. They are being added together, so I'm going to multiply the arguments together. Then I'm going to change it into exponential form, so 6 to the 1 is equal to x squared plus x. Then I'm going to rearrange and set it equal to 0, because now I see that I have a quadratic equation, which I can factor, and then I can solve. In order to decide which solutions are valid, I need to go back to my original expression, and I'm going to take a look at my restrictions. So this first one tells me that x has to be greater than 0. I also know that x plus 1 has to be greater than 0, which means that x has to be greater than minus 1. So the one that is the dominating restriction is that x has to be bigger than 0. This means that the x equals minus 3 is not a valid solution. So my only possible solution here will be x equals 2. E is a similar example, except my logarithms are being subtracted, so that means that I can divide my arguments. Then I can change it into exponential form. Next, I'm going to expand and simplify. So I've got 3x minus 6 is equal to x plus 2. Now I've got a linear equation. I can collect all of my terms with x on the left and all of my terms that are numbers on the right, and then I can solve for x. When I go back to my restrictions, I notice from my first argument that x plus 2 has to be greater than 0. So x has to be greater than minus 2. From my second argument, I know that x minus 2 has to be greater than 0. So really x actually has to be greater than 2. That is my dominating restriction. I can also see that from my rational function here that x can't equal 2. Can't equal to the number 2, which is also incorporated with this one restriction. So x equals 4 is a valid answer, satisfies all of my restrictions. So let's do a couple more examples. We'll go on to the next page. Here, I'm looking for the x is now my argument. And so the first thing that I'm going to do is I'm going to change this to exponential form. And then I'm going to evaluate. So this says that x is equal to 1 over 36 to the 3 halves. And then I can take the square root of 36 and cube it, and then I have 1 over. I'm going to go back up to the beginning before I evaluate. Normally, if I took the square root of 36, I would get plus or minus. So I can say that this would be plus or minus 1 over 216. My only possible solution, though, is the positive one because of my restriction that x has to be greater than 0. The value that goes into that argument has to be above 0. In the second one, we're going to find something similar. So my base also has to be greater than 0. So in this one again, x has to be greater than 0. I'm going to change my equation into exponential form, and then I'm going to solve it. So I'm raising both to the minus 3 halves. On the left-hand side, that leaves me with x. On the right-hand side, I'm left with 25 to the 3 halves, which means that I'm going to take the square root of 25 and then cube it, which gives me 125. Normally, I would have both answers if I was just solving that exponential equation. Because of my restriction on the base of the logarithm, x equals 125 is my only possible solution. In h and I, I've got multiple logarithms. So the first thing I'm going to do for h is I'm going to notice that they're adding, that they have the same base. So I'm going to multiply the logarithms together. Then I'm going to change it into exponential form. I'm also going to expand. So I have x squared minus x minus 2. Then I'm going to notice that I have a quadratic equation. And so I'm going to rearrange to set it equal to 0. I've got x squared minus x minus 6 is equal to 0. This one I can factor. I've got x minus 3, x plus 2 is equal to 0, which means that x equals 3 or x is equal to minus 2. My restrictions on my x are that x minus 2 has to be greater than 0, so x has to be greater than 2. I also know that x plus 1 has to be greater than 0, which means that x has to be greater than minus 1. This is the dominating restriction here, that x has to be greater than 2. So this solution is not valid. X equals negative 2. This one is, which means my final solution is x equals 3. My last example, I have logs on both sides. So what I'm going to do is I'm going to bring the coefficient up. so that I have log 4 on the left-hand side and log 4 on the right-hand side. This means that the arguments have to be equal. So I'm going to expand and simplify. And then I'm going to collect like terms. So I'm going to end up with x squared plus 5x plus 2 is equal to 0, which gives me another quadratic equation. Unfortunately, this one is not factorable, so I can use the quadratic formula. X is equal to negative b plus or minus the square root, b squared minus 4ac all over 2a. Here I can evaluate using my calculator to get approximately minus 0.438, or I can get approximately minus 4.56. Before we decide which answers are valid, we're going to go back and check our restrictions. So the first bracket tells me that x plus 7 has to be greater than 0. So that means I know that x has to be greater than minus 7. So with that restriction, both are valid. For my second bracket, I know that x plus 3 also has to be greater than 0. So that means that x has to be greater than negative 3. Therefore, we only have one solution. And those are some examples of solving logarithmic equations.